Hi, my name is Oscar Bernal Pedraza and I'm here to talk to you about distributive property. So, usually you get the book approach. The book approach is whatever you will find in a book talking about real numbers or complex numbers or polynomials or even rings if you go a little beyond, and you're going to get the definition. Distributive property means a times b plus c, so one factor times another factor that contains addition or subtraction. A times b plus c is going to be a times b plus a times c. So it's called distributive because the a gets distributed over the b plus c. That's the basic idea. And you get an example, let's say 7 times 100 plus 3. So you get 7 times 100 plus 7 times 3. You get 700 plus 21, 721. You can check on your calculator. 7 times 103 is actually 721. Everything works perfectly. Then you get another way to look at distributive property. You get the FOIL. So the FOIL is what happens when you have one factor with two addends and another factor with two addends. For our example, we have 5 plus 2x and then 3 plus 4y. So the recipe for the FOIL is do something like this, because the FOIL says you get the first. So the first means the first addend in each factor, in this case 5 and 3, and you multiply. So 5 times 3. And then the outer, so the way they are written now, the 5 plus 2x and the 3 plus 4y, the outer pieces are going to be 5 and 4y, so you multiply. Then multiply the inner ones, the 2x and the 3, and multiply the last ones, the last piece in each factor, so you are going to get 2x and 4y, and you are going to multiply. So finally, your answer, or at least the next step in your answer, is going to be 15 plus 20y plus 6x plus 8xy. In this case, we are finished because there is no way to do anything with that. I mean, there is nothing to regroup or something. So this is FOIL, but then suddenly you go to an exercise when you have 3 addends in the first factor and 3 addends in the second factor or something like that, and what to do. Now there is no sense of thinking about just the inner or the outer or the first or the last. It's not going to make sense. Where it's going to be the 6x and the 3c in this case, it doesn't make sense. So now we are going to explain distributive property in such a way that this makes sense, and hopefully you will be able to make sense of any application of the property. So we are going to try two different explanations. One explanation is what I call the ideal wardrobe, and the other one is going to be something like more graphic. So for the ideal wardrobe, my way to think about this is the first factor is just a set of jackets, and the second factor is just a set of pairs of shoes, and every jacket matches every shoe. That's fine. But then when you are trying to create an outfit, you are not going to try 2 jackets, you are not going to try 2 pairs of shoes. You are going to choose one here, one of the jackets, and one down, one of the pairs of shoes, and you're going to make every possible combination, so those are the outfits. So my explanation of the ideal wardrobe is think about all the combinations and make the multiplications. The graphic way is basically the same thing. I mean, it's going to be the same thing because it's distributive property. It's just a way to look at it. So you think about one of the factors being in one axis, the other factor being in the other axis, and all the crossings being the multiplications, and you just have to collect that at the end. So back to our exercise, 7 plus 6x plus 5y multiplied by 4 plus 3c plus 2w. So we basically go 7 times 4, 7 times 3c, 7 times 2w, and then 6x times 3c, 6x times 4, 6x times 2w. So everyone in the first factor with everyone in the second factor. So we get something like whatever you see in your screen now. And just to make it kind of clear, I did this in 3 rows. So the first row is 7 with everything in the second factor. the second row is 6x with everything in the second factor, and the third row is 5y with everything in the second factor. So you have 9 and you add everything. If you can do anything else, like anything on top of that, is good. In this case, is made to not happen. You are not going to be able to do anything. That's the final answer. Then you have to apply this kind of multiplication to, let's say, polynomials. So let's try something. X cubed plus x squared minus 2x plus 7 multiplied by 4x squared plus 3x minus 6. So you go x cubed times 4x squared, x cubed times 3x, x cubed times minus 6. Be careful with the signs. X squared times 4x squared, x squared times 3x, x squared times minus 6. So you do all those things and you get step 1. This is the final, let's say, final operation after distributive property. Not final, because we are talking about polynomials, and we get, for example, in this step, for the exercise we got 3x to the fourth, and we got also 4x to the fourth. So we have to add those. We have to combine the ones that allow us to combine. So the final answer is going to be something like 4x to the 5 plus 7x to the 4 plus whatever. And at the end we got the minus 42 because the plus 7 multiplied by minus 6. So just remember, if you're talking about polynomials, it's not only about distributive property, it's also about making sense of the terms with x to the same power. What happens with complex numbers? So let's think about minus 1 plus 4i multiplied by minus 7 plus 2i. Sorry about the about. So we do the multiplications. Minus 1 minus 7, 7. Minus 1 plus 2i minus 2i. Plus 4i minus 7 minus 28i. And plus 4i plus 2i plus 8i squared. It doesn't look like it should be the answer. Something is missing because a complex number you usually don't see I squared. What's happening? Remember, it's not a trick, it's just something that we should know. I squared is minus 1. So we do 7 minus 30i because the minus 2i and the minus 28i are already kind of combined, and the plus 8i squared turns to be minus 8. And finally we got minus 1 minus 30i. That's the answer. So what happens when you have more factors? When you have more factors, it's basically the same explanation as the wardrobe. Just think about, for example, scarves and jackets and shoes. So you get one scarf, one jacket, one pair of shoes, and you do the combination. It's the same here. One in one factor, one in the other factor, one in the final factor if you have 3. If you have 4, the same thing. So try yourself. X plus 2 times 3x minus y times 2x plus 5. Be careful about the organization. Make sense of the number of factors you are dealing with and the number of results you are going to have in the middle process. Your final answer should be 6x cubed plus 25x squared plus 21x minus 10. If you got that, perfectly fine. If you didn't, just check maybe something you did twice or maybe something you missed. Then it's kind of easy. Just try to be organized. That's going to be all. And now that you did this exercise, that you worked with distributive property, hope you understood, hope you will be able to apply in any other exercise. Thank you for watching.